So we'll start with Euclid geometry. Okay. Or you want coordinate geometry?
We can do Euclid geometry.
Okay, fine. Let's see. Nothing is left in the polynomial. No? I think we already did these examples. Okay, these I think we have not done. Let's see 1 or 2 more examples, and then we will start with the Euclids. Okay.
Yes, ma'am. Ma'am, I can only see the syllabus scheme.
It will take a little time to synchronize, I think.
Yes, ma'am. Now I can see.
Okay. So let's evaluate. So evaluate 1 over 4 to the power 3 by using suitable identity. So which identity you will be using? I think we have already discussed. 104 can be written as what?
100 plus 4.
Yes, 100 plus 4. So we already know A plus B whole cube formula is what?
A cube plus B cube.
Yes. Expand and tell me. Can directly write it as directly. No, it is more. So have you got the answer?
Yes, ma'am. Yes, ma'am. Same also.
Same
And we can write that
Okay.
A square B plus 3AB square as 3AB into A plus Q.
Yeah, same. You can write that way also. Okay. You are saying this now that A cube plus B cube plus 3AB A plus B. You can write this way also. Okay. There's no problem. Okay. In the both the ways you write. Actually, they are the same thing. Okay. Now try to do this one. Actually, you will be having your test now, so I thought I will take the class. Now, if x square plus 1 upon x square is equal to 7, find the value of x cube plus 1 upon x cube by using the positive value of x plus 1 upon x. Okay. So what is given, you have to relate it to find out this. Okay. You have to find out the value of x cube plus 1 upon x cube. Okay. Using only the positive value of x plus 1 upon x. Okay. So first of all, let's see that what this x square plus 1 upon x. Okay. A square plus b square plus 2ab. Okay, if we write here x square plus 1 upon x square is equal to 7. So I think you can write it's a square plus 1 upon b square plus 2ab. So you'll get only 2 here. Yes or no? Yes. So 2 is not here. Other things are here. So what we can do, we can add 2 on both sides. Yes or no?
Yes,
Sharon, add
Yes.
2 on both sides. Adding 2. So you'll get x square plus 1 upon x square plus 2 is equal to 7 plus 2. So this will become whole as x plus 1 upon x whole square is equal to 3. 8, 9. It will become 9, and 9 can be written as 3 square. Yes?
Yes.
Yes or no, Shell? So
Yes.
what value we have got? We have got the value of x upon 1 upon x is equal to 3. Okay. So this is the
Yes.
first we have got the value of x plus 1 upon 3. Now let us use the formula of this where we'll get so that we can find out the value of x cube plus 1 upon x cube. Okay. Now let's cube do the cube on both the side. Okay. This same equation we are going to do cube. Okay. When you are doing the cube, cube on cubing on both sides. So if we are going to do cube on both sides, so x plus 1 upon x whole cube is equal to 3 cube. Okay. Yes. So it will give you what? X cube plus 1 upon x cube. Yes. Plus 3 x into 1 upon x. So it will be cancelled, and then it will be x plus 1 upon x. Yes or no? Is equal to
Yes.
357. Okay. Now you need to find out the value of this. Okay. And we already know the value of this number. What? X plus 1 upon x is equal to 3. So what we can do, we can directly bring that thing into next side, which will be equal to 27 plus is equal to minus 3 into what? 3 into 3. So which will be equal to 9. Actually, I'm directly writing. So it will be 3 into 3 is equal to 9. Okay. So 27 minus 9, what you will get? You will get
18.
Okay. So what the answer?
Yes.
Understood?
Yes, ma'am.
Okay. Let's try another. Try this one, Sharon.
Yes, ma'am.
If a plus b plus c is equal to 9 and ab plus bc plus c is equal to 40, then find the value of a square plus b square plus c square. You already have the formula. Do you remember the formula? Which formula you will be using here?
It is the a plus b plus c whole square, but now I don't remember the expansion.
And this formula is here. This formula is here. Oh, where is it? This one. No, not this one. A plus B plus C. Yeah, you can use this one only, okay? Because A plus B plus C value is already given. A plus B plus C is equal to, see, here we know the value of A plus B plus C is equal to 9 is given, okay? So you can do square on both sides, okay? So if you're doing square on both sides, what you will get this side? Okay? A plus B plus C is equal to 9. We're squaring the what you will get? It will be a square plus b square plus c square plus 2ab plus 2bc plus 2ca is equal to 9 and 0. Okay, this will be what we have to find out. We are it is given the value of ab plus bc plus ca is given 40. Okay, and we need to find out the value of this. We need to find out the value of this. Okay, so it can be written as a square plus b square plus c square plus 2 common
Plus
ab. What is the value given? 40
so 80
will be 1. Okay, so value of a square plus b square plus c square is equal to 1. Shannon?
Yes, ma'am.
You have to remember the formulas. Okay, if you remember the formulas, you can adjust it. Okay, sometimes you need to think, you need to add up something, or you need to do square on the both side. If you remember the formula, na, you can write it on the rough side and then just your what is it? Okay. Now problems based on geometrical figure. Okay. Now same type you are going to use formula, but it's based on geometrical figures like square, the scale length, breadth, all this kind of thing. Okay? Now, see, sometimes the problem is given in the form of base of area or volume or geometry. Let's see the question. Okay, only 2 examples I have given you here. Give possible expression for the length and breadth of the rectangular whose area is given by. Wait, let me copy. So, what do you think? How can you solve, Sharon? Possible expression for the length and breadth of the rectangle whose area is given by 4a square plus 4a minus 3. So, you have to give expression for length and breadth of a rectangle. Its area is
Ma'am,
already
your voice
given.
is
So, would
breaking.
be breaking too much?
Yes, ma'am.
Is it okay now?
Yes, ma'am.
Okay, what we know about this area of a rectangle? How can we express area of a rectangle in form of length and breadth? Length into breadth? Yes or no?
Yes, ma'am.
Your area is given as 4a square plus 4a minus 3. So you can see that it is a quadratic polynomial. So we are going to use middle term splitting. Okay. You see, so middle term splitting means we need to split this.
Yes, ma'am. I got the answer.
So what do you have got?
I got 2a minus 3 into 2a plus 1.
2a plus 1 and 2a minus. Are you sure?
Okay, yes, ma'am.
Sign. Yes, is correct, but what I have got it is 2a minus 1 and 2a plus 3. So among this, one will be your length and one will be your breadth. Okay. Maybe your sign will be wrong. Here you have put the wrong sign. Okay. Check the
2a
sign.
minus 2a plus 1.
See,
You have got
before 3 minus sign is there. Okay, Sharon. Before 3 minus sign is there. So after subtracting, you should get 4.
okay. But I put plus 4a. It is actually I put minus 4a. That's why I got the different answer.
Yeah. So anything among this, maybe 2a minus 1 is the length and 2a plus 3 is the breadth, or maybe 2a minus 1 is the breadth and 2a plus 3 is the length. Okay. Now, similarly, what are the possible expression for the dimension of a cuboid? Okay. So cuboid means the three-dimensional structure of a cube. Okay. A square, sorry, a cube or rectangle. Okay, so whose volume is 36? So volume is given. So volume of cuboid is what? Length into breadth into height. Okay, length into breadth into height. Volume is all the 3-dimensional multiplication. Okay, so here you can see according to what is given, it is if you take the expression 36 kx square k kxy, we can take x cannot be taken, y again. So if you're taking common, so what we got? Let me copy and explain it. Okay, the expression here is say 36 k x square y minus 21 k x y square 3 k y cube. Okay, x is not there in the third one, so we cannot take x as common. But from the rest, all expression, if you see, we can take 3 k y is common. Yes. So what will be remaining in the first one? 12. Yes. 12x square minus 7xy plus y square. Okay. Yes or no? So if you see here, it is of the form a square plus b square minus 2ab. Yes or no? Okay.
Yes.
But here 12 is there, na? 12 is not in the form of a square, because 12 square, if you met 4, it is 24. Okay, we can use a middle term splitting. If you use middle term splitting,
we can use 3 and 4 minus 3xy plus 4
not middle term splitting exactly. We can use and then take common. Okay, we have to find length, breadth, height. So in 3 expression, it should be there, na? So 4 common, we can take x. So we got the same as between 4x minus y and 3x minus y. Okay, so actually we got what? 3xy, 4x minus y, and 3x minus y. So among these three, one is the length, and one is the breadth, and one is the height. Okay,
Yes.
understood?
Yes, ma'am.
Any doubt?
And can you explain the factor method of factorization that we learned previously once again?
Factor method. Polynomial you're asking, na? Hello, Sharon. Am I audible?
In the factor
Hello?
theorem. Yes, ma'am.
Okay, you were not audible. Okay, you have to understand about the factor theorem. So I think you understood about this.
Yes, ma'am.
Very
This
well.
I
Now,
understood.
so in factor theorem, you have two conditions. Okay, two things are there. Okay, and what does the factor theorem say? The statement of the factor theorem is that factor theorem. So among this, you can understand that it is talking about the factor. Okay. Now, let px be, and since we are dealing with a polynomial, so we will be taking a polynomial. Okay. And to be a polynomial, as a specific polynomial, a proper polynomial, at least it should have a degree of 1. Yes or no? Do you agree? Okay. Otherwise, if it is a constant polynomial, only one number will be there. Okay. So for a proper polynomial, will be. Okay, let me rejoin. Okay, rejoin. Okay, Sharon. So in factor theorem, we are actually talking about the factors. Okay, and now we'll be taking a polynomial for a proper polynomial. So proper polynomial means at least the degree should be 1. Okay, it can be greater than 1, but the minimum should be the 1. So the value of n, which is defining the degree of the polynomial, will be taken as greater than equal to 1. So a polynomial is there, px, fx, whatever polynomial, we're assuming it as px right now. So polynomial px is there whose degree is greater than or equal to 1. Okay, and a be any real number. What is this a? The real number that we are taking. Okay, a proper real number will be there. Okay, then if we are going to place a instead of x, okay, in the polynomial, if and the whole value of the polynomial becomes 0, that means what? That x minus a is a factor of px. Okay, x minus a is a factor of px. See, not having a polynomial, like for example fx, okay, and instead of this x, we are replacing this x with a, and what is this a? It is a real number, any real number. Okay, and if after putting fa, we get what it is as 0, if we are placing a instead of x in the whole polynomial equation, and we are getting the value of the polynomial. Value, you understand now? The complete value of the polynomial as 0, then you can say that x minus a is the factor. Okay, you are putting here a, so it will be, that means you have placed x is equal to a. Okay, you have, instead of x you are putting a. What does it mean, Sharon? That x is equal to a? Yes or no?
Yes, ma'am.
Have you understood that? That you are replacing x as a. How can you replace something? If it is equal to, so we are taking x is equal to a. Okay. So
Yes.
what will be the factor? You have to bring a on this side. So a x minus a will be equal to 0. So x minus a is the, if f is equal to 0, then that means x minus a is the factor of the polynomial, given polynomial.
Yes,
Okay.
ma'am.
Understood? Similar
Yes,
two
ma'am.
conditions are there, and the otherwise vice versa, that if x minus a, now we will go from the bottom, if x minus a is a factor of the polynomial, then f is equal to 0. If x minus a is a factor, that means x minus a is a factor, that means if you are going to divide from x minus a, it will give 0. That means x can be placed, x can be equal to a. Okay, so if we are going to put fa, then it will be equal to 0. These two things are only written in the factor theorem. It is talking about you from the name itself, about the factor. Factor is what? If I'm saying 2 and 3 are dividing 12, so they are the factors. Okay,
Yes.
Sharon? Okay, so
Yes.
it is nothing very complicated. You are taking a polynomial, just a polynomial you are taking, and to be a proper polynomial, its degree should be greater than equal to 1. Now you are using, instead of x, you are putting a value there. Okay, and right now we are not exactly defining a value. A key value, we cannot take only one single value, 2, 3, 5, 6, 7. Okay, so we are taking any arbitrary number which is a real number. Okay, a real number we are taking, and right now we are representing with a symbol a we are representing. Okay, but it is a real number, it can be any real number. Okay, and when you are keeping this a, when you are putting this a instead of x, so actually x is equal to a. Okay, then only you are replacing x. Now you are putting x is equal to a, so instead of x you are replacing it with a. So x is equal to a. If f a is equal to 0, then this x minus a will become what? The factor. And if f minus a is equal to 0, then x is equal to minus a you are putting. Plus a is the factor.
Yes, ma'am.
Got it?
Yes.
Yeah. Just read once more. Okay, nothing much is there. Okay, you don't have to complicate the things. Okay, just a polynomial is there, and you are finding factors. Okay, and how you can find a factor? Instead of x, you are going to place a number there, and it can be any real number. Okay, it can be 1, 4, 5, 10, whatever. Okay, so you have to define some variable. We have to represent it here in the definition as a variable now. So that, for that we have used an a. Okay.
Yes, ma'am.
So if fa is equal to 0, then x minus a will be the factor. If f minus a is equal to 0, then x plus a will be the factor. Okay, and vice versa, means just the opposite. If we are moving, that if x minus a is a factor of fx, then fa will be equal to 0. Okay, that means, see, if x minus a is a factor, so there will be no remainder. Yes, no. If you are going to place a instead of x, there will be no remainder. Is equal to 0.
Yes, ma'am.
Now it's already the time, but I'll just give you a little introduction of Euclid. So Euclid geometry. Okay, actually here Euclid was there. Okay, Euclid is a person who has worked for geometry. Okay, the definitions of your geometry. Okay, and geometry is what? It is related to the measurements, and actually here weather is little not okay now, so that's why I think your network, my network is little weak. Still, is it breaking? Hello, Sharon.
Yes, ma'am. I can hear you, but it's not really clear.
My voice is not clear much.
Yes, ma'am.
Okay. Okay, then from next class we can start with Euclid. Okay, I think you are having class on Thursday. Yes, Sharon. Okay, I will place everything. You have access of Alamkul app. Do you have access of Alamkul app?
Yes, ma'am.
Okay, so I will place all the notes there. Okay, in the Alamkul, all the notes and the material related to Euclids. Okay, we go through them before the class. Okay, and then we will discuss the chapter in the class. Okay.
Yes,
It will
ma'am.
make things more fine and smooth. Okay, so that if you have any doubt, you know beforehand, and if it is clear in the class, that's okay. And if it is not, when I'm explaining, you can ask me again. Okay, Sharon,
Yes, ma'am.
is that fine? So I am assigning you assignment also. Okay, all the questions in that, let me check. All the question in that will be related to your whatever questions we have done in the class. Okay, and in the after that next assignment class, I will give you the new assignment. Just let me check first. Yeah. 5.1. Sharon, my screen is visible.
Yes, ma'am.
And this is the assignment I'm going to assign you today, and you can see all the questions we have already done it in the class. Okay, you can see all these questions we have discussed already. All the question in
Yes,
this exercise is already done. So you can complete it itself today itself. Okay, and you can submit it. Okay, Sharon.
yes, ma'am.
Okay, so I'm assigning you in the Alamkul app. Do you open Alamkul app?
Yes, ma'am.
Okay, that's good. Okay, for today's class. Okay, Sharon, I have already assigned you. You can check in your Alamkul app, and then you can do the assignment. Okay, all the questions in this assignment are done already in the class discussed, and the next assignment that you will get on, I think, Friday, will be some questions related to this. Okay, and then there will be a polynomial chapter is already complete. Sharon?
Yes, ma'am.
Okay. So till then, bye bye, Sharon.